So, as you can see here, we have a quarter fan spinning board. Now this isn't just any quarter fan spinning board, this is a quarter fan spinning board that has been ultrasonic before it got here. This is also a quarter fan spinning board that has no signs of liquid damage whatsoever. So, let's see if we can get any clues as to what's going on. Now my first area to always check on a 2936 or 3115 board is going to be the RTC area. It's in a very bad area that if it gets hit, it's right at the edge, so it's very prone to getting liquid damage. And another thing is this chip doesn't have to look corroded to be bad. Any little bits of liquid will destroy it. So let's look closely at this chip. Remember, this was ultrasonic. Okay. See that little bit of stuff right here? Okay, that looks like it may have got a little liquid there. Let's continue on. Another area that I was already probing around at is right here. Little bit of liquid might have got there, and if it might have got there, it might have got the PCH too. Other than that, this board looks absolutely clean. So let's go over quarter fan spinning. What is quarter fan spinning? Basically, it's power cycling. The board is powering up, reaching an SO state, and it's going back to an S5 state. It's simple as that. It's just power cycling. What can cause quarter fan spin? Anything. It's one of these things where anything can cause quarter fan spin. Little knocked off resistor somewhere can cause quarter fan spin. Pretty much anything can cause quarter fan spin. So let's go ahead and get our meter. Let's start checking some of our rails. We know it's reaching an SO state because that fan pulses. The fan runs off of PP5VSO. It's reaching an SO state, it's turning, and it's shutting off. So we know it's reaching an SO state, so we're okay there. Let's check, of course, if we're reaching an SO state, we're going to have PP bus G3 hot, 12.56 volts, which is normal. Let's see if we have PP3V3 SO. I'm going to open the board view here. Let's see. Let's go off microscope view real quick. Under the board view. This is a 2936, which is almost the same thing as a 3115, just a little bit older. So PP3V3 SO. It's going to show up pretty much in a few places. Flip it over. We'll check it. We'll check it right here. We go back to the microscope view so you can see. That is going to be right here. Another thing that can cause this is shorts on the SO rail. And we have pulses up to 2. Oh, wait a second. Yep, we're pulsing, so we're good there. So another thing to check is CPU V-core pulsing. So, as many of you know, you don't even need a schematic for this. V-core shows up on these coils. So V-core tends to pulse faster, so we may not get it on the meter, especially with my batteries being weak. But let's check. So far, nothing on the meter on the 20 volt scale, so let's drop it down to 2, and let's see if we get any pulses on the 2 volt scale. We get nothing. let's go down to the 200 millivolt scale and see if we have any signs of pulsing on CPU V-core. Nothing. So we have nothing on CPU V-core. That's a clue for something. Now, basically, CPU V-core issues. I don't think the CPU V-core circuit is at fault, and on this board I already threw a new U7400 chip on just to try it because I didn't feel like thinking. We're going to check resistance to ground on CPU V-core. I don't know what it's supposed to be for this board. We have 6 ohms to ground, that's fine. I don't think there's an issue with the CPU shorted to ground. I don't think there's an issue in the CPU V-core circuit, but what does the CPU have to do, or the PCH rather, is send out power good signals. The PCH has to send out a bunch of power good signals for a bunch of signals to enable different things. And what if the PCH isn't being told what to do? What if the PCH is not working right, or it's not being told what to do? And here's where our RTC circuit comes in, because the RTC is going to put everything on a timer, and if that's absent, then nothing's going to work. So let's go ahead and check PPV RTC G3 hot. And that's going to be, I think, on one of these caps right here. Let's just double check on the board view. So let's go over to U2800. I'm guessing it's going to be, no, which one is it? So what U2800 does is it generates a 32 kilohertz clock signal, and it generates PPV RTC G3 hot. So that's going to show up on this cap. And we have 3.3 volts, no issues there. But is this chip sending out our 32 kilohertz clock signal? We don't know. So let's go ahead and look. We can't measure this with an oscilloscope. We could go ahead and check voltage to see if it's coming out completely dead, partially dead, or you know what I'm saying. So it's going to show up on these 2 resistors right here, and that's 0.3 volts, and it pulses up to 0.8 volts, so it's pulsing. Okay, now notice something. When the 32 kilohertz clock signal pulses, now it's not pulsing at all. Wait a second here. Okay, so we had a pulse. So when the 32 kilohertz signal pulses, we get fan spin. Okay, what does that tell you? Something may be messed up there. I'm not 100% sure, but this is an educated guess that something is wrong with this chip, and we're going to go ahead and change it. Quick note, this board uses a, let me look, it uses a SLG3NB14V, or 148V I mean. 148V and 148A are interchangeable chips. 148CV is not interchangeable with the older one, so make sure you get the right chip or it won't work. Let's check comments real quick. No comments. Alright, let's go ahead and swap this chip. We're going to take orientation. We can see that pin 1, dot on pin 1 is up towards this corner, towards the cap. Always note orientation. We're going to go ahead and kick on the fume extractor and take off that chip. Put our quick on. And this is right by the PCH, so we want to kind of blow air away from it and not towards it. We don't want, that's not good if we're blowing it towards it. But it's not going to kill it either. It has a heat sink on it. The board's cold, so I want to kind of Now, sometimes this can be flux, right? This was not flux. This has liquid under it. You could clearly see it plain as day, there was liquid under that chip. That is not flux. Why do you think recorder fans spin? Clock chip ain't gonna like that, so that's looking good right now. That's what I like to see. I like to see liquid damage under chips. And this was ultrasonically clean, but ultrasonic cannot hide everything. You will still notice some signs. So don't, give up if you see something that's been ultrasonic. Now, this could also mean that it's under my PCH and messed up my PCH because it's right there. So, fingers crossed that it's not. Feed some nice leaded solder in there. Get some fresh cut on our wick. Also, another thing that I'm deciding to start doing is hard drive board repair. So if anyone needs any boards and drives fixed, when drives don't spin up or anything, we are now offering that service. I'm not going to do the rest of the hard drive stuff, just the board repairs. I want to keep everything I do confined to board repairs. I was thinking about doing the platters and stuff, but I don't really care for it that much. I mean, I don't have a clean room. I know you don't really need a clean room on a lot of stuff, but I just would rather stick to board repair. I don't like to mess with data too much in boards, or I'd rather stick to what I know, and that's board repair. Go back to the comments. Nothing new. Now the center pad, remember, this is pretty critical, so don't overload this with solder. Just get enough on there. You don't need a whole bunch. All that's for is a thermal pad, so don't worry too much about getting, too much solder on that. Sometimes it could be do a lot worse. Let's get our donor chip off this board. Where is it? This looks close enough. I better double check. It looks close enough, and I'm pretty sure that's the clock chip, but I will double check. A lot of stuff on some stuff like DCN inputs to 3V42. It doesn't have to be the exact resistor. Some of them use a 0 ohm, some of them use a 1 ohm, some use a 47 ohm. It really doesn't matter. Put something that'll work. Now some stuff is critical, some stuff is not, but like DCN inputs, or let's say your 12 volt inputs to stuff like that create another rail, usually that's not too critical, and you can get away with using a different value resistor than what's spec'd for it. Of course, don't just go and think you could replace any resistor with any value still, Take a little care and consideration. Actually, I want to prepare that area a little bit better. What I noticed is when I leave old flux and just put new flux, it ends up bridging. If this doesn't work after this, I don't know. Quarter fan spin could be anything, and it's probably not worth my time given there's ultrasonic, but I'm pretty sure I know why that wasn't working. So especially on ISLs, I noticed that's where it happens the most. Always clean up your flux because it'll create little bridges under the chip. I don't know why, I can't explain why. I don't know if it's just me, but I just like to clean it. And then we could put a fresh layer of Amtech 559, which the flux in the solder doesn't really work all that well compared to this stuff, so put a little bit of fresh 559 on there, and that's designed to still be effective after a little bit of heat. Get rid of my wireless keyboard. Now, as any QFN chip, we're going to lower our airflow way down because we don't want this to get blown away. Just kind of get it close, doesn't have to be exact. This chip is easy to solder, I have to admit. Fell into place on the center pad, it's not going anywhere. So now, just keep heating it. You can still see some of the pads aren't. Okay, so now it's soldered. Now I'm going to pull away. Not done. I'm just going to pull away. Put some more flux on there. Now I'm going to put my tweezers on it. I don't like to put my tweezers on it while it's liquid. It tends to go a little bit off alignment. So while it's dry, get your hot air and let a nice blob come out. Hold the heat there for another 5-10 seconds just to be sure we are good. Now we're going to clean that up. Some flux. And hopefully this will work. Because if it doesn't, this is going to be probably a rabbit hole and I'm not going to waste too much time on it. Don't waste too much time on stuff like this. It's quarter fan spinning, it's been cleaned, you know. If there's signs of liquid, by all means, investigate, but if it's been cleaned and everything. Alright, what do you think? Does it work or does it quarter fan spin? If it quarter fan spins, it's a very good possibility this isn't going to work, but well, if it does. No green light. How is that? What do we screw up? Or is it the DCM board that screwed up? Orientation, right? I don't think it's shorted anywhere. We have a dim green light. That could sometimes be the DCN connection. So that runs out PP3B4 too. Let's see if maybe we got a dud chip. That can happen from time to time. Stop abusing Macs. I'm never going to stop abusing Macs. Macs are evil and they should not be on this earth. So, do we have any bridges? Nope. Let's go over here. Let's see if 3B42. I think 3B42 runs off of, or this chip runs off 3B42. So, let's go over here to the PP3B42 G3 hot. Let's see if it's shorted to ground. So pin 13 of that chip. Let's check pin 13 to ground to see if we shorted it. If not, it's probably my DCM board is being flaky. But you never know. Could be 3B42 shorted to ground from a dud chip from the reel. That happens. It doesn't look like there's a short. There's no short on 3B42, so it's not my problem. That's not my soldering on my chip. It's probably my DCM board, or there's another issue on this board. And we're still quarter fan spinning. Why? So, still quarter fan spinning. Wonder if our no, the crystals really don't fail that much. No, it does. This doesn't look too bad. But let's check if we have continuity from the crystal to chip. So we're good there. And there. Now this other one. Alright, we're good. So, what's our other cause for quarter fan spin? Let's see. Nice to see someone else using the light theme for open board view. The thing is I just, usually I switch it to the dark. The light's not bad, but I just got this desktop yesterday. What I noticed is the reason why I didn't use the light, the main reason is because anytime I was trying to take a picture of my screen or something, or if you had the camera that I had that was mounted towards the back, it just looked bright and you couldn't see what I was doing. When the dark you could, because there's a time I didn't want to do screen capture or anything. But yeah, the light's not bad at all. I like it. And now that I'm doing a different setup, I won't need to switch it to dark. So. Alright, so what else can cause quarter fan spin? Let's plug it in. Let's do a diode mode to measurement. Does PM sleep as 5L? Let's see. Does PM sleep as 5L pulse? Because if our S5 rails are cycling, that could be a source for a problem. So let's check and see which rails are there and which rails start cycling to see which where a problem is. Let's check PP5V. So PP5V SO. PP5V SO is going to show up over on the other side of the board. We'll measure it. Here's a good, nice test point. Nowhere. Measure it near backlight. So PP5VSO. Not PP5VSO, I'm wrong. PP5VS5. So PP5VS5 is going to show up near U7200. That's going to be this chip right here. It's going to show up on this cap right here. So let's measure to see if that pulses. If that pulses, that's kind of good news because it's further back in the circuit and should be a little bit easier to solve. So that's steady, but I see something funny. Now, our 5-volt rails are technically coming online, right? But that looks a little suspicious, I think. Let's see if we can dig and see. There's a little hole in it. There is a little crater in that chip, but if it's giving our S5 rails, I don't think we have to worry. Let's look at the schematic. So switch over to schematic here. No, not mail, schematic. And let's look at U7200. So, yeah, if we're getting our S5 inputs, let's see. BP bus S5, HS other, iSense. So this is for our CPU. Maybe. Do we have that? Because if that's missing, that could definitely cause our quarter fan spin, and that would explain why we are missing our V core. So it's going to show up, it looks like, on the inside or on these caps. Let's see, switch back to AmScope view. Let's plug it in. If that's missing, that would make me happy because that would be easier to solve. Now we're dead altogether. Did I kill it by digging in the crater? No, there we go. Fan is spinning. That's ground. I confused myself. So ground, and we have 12.56 volts there. Come on, really? 12.56 volts. And V core. Alright, so U7200 we replaced. This needs so here's our CPU V core. That's going to be IMVP gate 1, phase 1. Do we have anything on this FET? Let's rotate. So, let's see, do we have our inputs from U7200, U7400? We'll come up on this FET, let's check, it's going to be come on, pulse. Nothing. Nothing. So we're good there. We should have, that should be, yeah, we're good. Alright, so my guess now is going to be something around U7400, like already replaced, like someone that doesn't know how to fix boards. So let's look. Do we see anything obvious? No. Let's look at the U7400 circuit on the schematic. So U7400. This thing. So we're missing all the pulses to the CPU, and that's telling us something. And when I got this board, I was hoping that I could have a quick fix, and I changed the chip, and obviously it wasn't that. So if you look over here, U7402 CPU IMVP T on, time on. So let's check U7402. It looks fine, in my opinion. but we are going to check it. So alright, we have 12 volts on one side and 12 volts. That doesn't sound right. CPU time on should not be 12 volts, I don't think. Or should it? Am I measuring the wrong thing? No, I'm measuring the right thing. CPU IMVP time on does not sound like it should be 12 volts. CPU VR voltage regulation on is pin 1. Do we have CPU VR pin 1 now? Is that that's the at least we know the resistor is good. It's not blown. So CPU VR on, which is CPU voltage regulation on, is 0 volts. Let's go to the schematic U7400. Okay, so this is an input signal, CPU VR on. It's a enable signal. So without this, okay, without this, none of this is going to work. Start at the beginning of the circuit. Look, input, EN, enable. Okay, if this is not enabled, nothing will work. Now, CPU time on, it's going to go through. Okay, that's normal for that to be 12 volts. That's good. These are output signals. None of these are going to get outputs. How can we possibly get any of these outputs, okay, without an input? So let's check these other inputs. CPU VID S out. No idea what that does. I have no idea what this does. I have no idea what this does either. But let's check these. So CPU VID. We can't even. CPU VID S out. It's going to be on pin 16. No, I don't feel like measuring that. So CPU VR on, and where's that going to come from? So let's find out where CPU VR enable comes from, and that will probably be why having our issue. But where does that come from? Alright, so CPU vCore enable comes from Allsys Power Good on U7490. Now we're getting a pulse on Allsys Power Good. I did check that. So Allsys Power Good U7974. So U7974. Where does this show up? So search U79 R7974. I have a feeling, no, I did not mess with that. So R7974 is up here. I think, let's see, which side is this on? This is on the compute side. So this side, and it's up near the RAM above this coil. That's no stuff. It's gotta be. Wait a sec. So it's the middle one. No. So something's wrong here. No, that's right. So CPU VR on comes from Allsys Power Good. Now let's see if Allsys Power Good is coming high, or what we get on the other side of this resistor. If Allsys Power Good is pulsing, we know our issue is not related to, or mostly not related to the CPU. Come on. No, now it's dead altogether. Wait, no, it's not. Just started to spin back up. Alright. That's weird. Alright, so it's not doing anything now. There's no fan spin, there's nothing, so maybe this could... I'd take a dead board over a quarter fan spin board, so let's see. Inside the resistor. Nothing. No Alsys, power good, so something's intermittent. Come on, spin up. There we go. So sometimes your DC in connection. So CPU IMVP VR on is pulsing, I think. And Alsys power good is pulsing to 1.22 volts. Okay. So now we are getting vCore enable. So if we're getting that, we should get something on our vCore signals. Let's see. Okay, so Alsys power good. If Alsys power good is not coming high all the way, where does Alsys power good come from? It's got to come from something. SO or LP good circuitry. This is an ISL, and that's ISL version in development. What does this mean? Use a U70 7960 1V05. I wonder if we have a 1V05 rail short. That would explain our quarter fan spin, because it's going to see that one of our 1V05 rails is shorted. It's going to kill the power good signal. So let's look at U7960 and see how that looks. So U7960 is going to show up. Is going to show up at this side of the board, which is really not in a very common area for liquid, and of course it's a no stuff. It's a no stuff, but everything there looks fine. I have an idea. So let's start going in line and let's see which rails are pulsing. So we have to figure out which rails are starting to pulse. So let's look at the schematic at the power rails. 1 second here. Alright, so let's see if it's just the SO rails pulsing, if it's the S3 rails pulsing, and let's see if we can inject power and see if we can get the board to start normally. Now, I don't recommend doing this unless to the last resort. I'm trying to figure out what's going on. Is our CPU at fault causing it? Is something, what's going on? So let's look. Let's just look at our S3 rails real quick. Actually, the one thing I want to do before is check our 1V05 rails. So 1V05 SO, do we have a short on 1V05 SO? If we did, that would be nice because that's easy to find. Well, I'm not going to say easy, but I don't like this showing up here, so let's go over to here. So, this mess of caps over here. That looks all suspicious there. So, any one of these 1V05 shows up. And hey, we have a dead short to ground on PP1V05. That's why we're quarter fan spinning. So, what we're going to do is inject a little bit of power. Let's get our trusty FLIR. Or this rail has just normal resistance to ground and I'm just being an idiot, but let's see if anything gets hot. Let's first turn on our power supply and set it at a reasonable voltage. I'm going to start at like half of a volt, honestly. Okay, we do not want to pump voltage into here because we will end up with a fire. So let's set this down to do half a volt. Why not? And here goes nothing. So that's going to show up right here. Hopefully something gets hot. And someone could be watching us laughing because this may be a rail that has a very low resistance to ground since it's related to CPU. Someone's probably laughing. I don't think this is short at all, actually, because look on Lewis's form, because I don't honestly know. So P1VO. I'm guessing what's going to happen is our CPU is going to get warm because this goes to the close to the CPU. It's pulling not very much amperage. Nothing getting noticeably hot. Let's flip it over. Nothing getting noticeably hot on this side either. Oh, that's why nothing's getting noticeably hot, because I didn't have this soldered, or it wasn't plugged in. No, it came off. Alright, since these two guys are the same, we're gonna do is just get a nice little solder blob so it won't fall out again. Just a nice little bridge there. And this time I'm gonna try 1 volt because 1 volt seems a little more appropriate. Said for all I know, this is normal for it to be at that, but I don't know. Okay. Adjust our voltage. Try 1.05 volts. That's a little high in amperage wise. Getting hot. I think getting warm is the CPU, nothing else, so I don't think that's an issue actually. I just think that rail is supposed to have low resistance to ground. Oh, I know what I can do. I could check on a another board. Well, it's probably going to have everything removed off of it, but checking another 2936 and see what we get. Again, it's probably going to have much of everything removed. But maybe, just maybe, is that 20? Yeah, this is a 2936. Yeah, see, it's not short on this one, but I think it's just because the CPU is connected to that line, and I think that's pretty normal. So we're running out of options here of what could be wrong. Let's go ahead and trace our way back and see if we could let's try pp5v_s4. Doesn't have an S. pp3v3s4. That's up here. No. We can measure that. I don't like those probe points. Yeah, I guess I will have to. So it's gonna be ECM board is flaky. Let's see if our S4 rails are pulsing. So S4 is stable. Let's look at our S3 rails. Okay, so S3 is pulsing. It's something on the S3 rail causing it. As many of you know, so PP3v3, I mean, you need S5, S4, S3, SO. So if something's screwed up on the S3 rail, we're not going to get SO or anything like that. So let's start looking into, 20. Wait. So PP3V3, S3. Now let's see. Do we have? Let's check PP5V S3 as well, because if we could localize it to one particular wait a sec. Alright, so one of these big, it may very well be so PP5V S3, plug it in. It may be the chip that has a crater in it. Now we get nothing, no fan spin. We have no fan spin, and what is so PP bus G3 odds normal, so we have DCN, everything, the SMC is working. Do we have our 5V? So we have no pulses on our S3 rail. Let's try and get it to pulse again. Let's reset the power. I think something's going on. So now we're just dead. Just dead completely. So let's go ahead and check. So 5V S5. 5V S5 is there. PP5V S3. Is nothing. We'll check over here. Nothing. So PP3V3 S3 is going to be up here and is stable, but our PP3V3 or PP5V S5 is dead now, and that's why we have no fan spin. So we're getting closer, we're onto something. So let's go ahead and check for a short now on 5V S3. Short. Let's check. Healthy diode mode to ground, no short whatsoever. So we have no short, but it's not coming online. So PP5V S3 seems like it's our troublesome rail. Okay, now it's pulsing again. Well, I just use diode mode while the board was on. That's a stupid thing to do. So, while 5V S3 is pulsing. Alright, so now we have our S3 rail that is, I think, oh wait, no, S4 is stable. Okay, so it's something getting screwed up in the S3 power state. Now it's time, wait a sec, no, I'm wrong. PP3V3 S3. So PP3V3 S3. Show up over here again. So both our 3v3 S3 rails are pulsing. So let's look at the schematic of how the board generates our S3 power rails. So let's go over to the schematic. P5V_S3. Is enable L pulsing? Probably. want to see where this is generated, not. Okay. I want to see what's common to both the 5-volt rail and the 3-volt rail. So, looks like this is gonna go Q70. It looks like, I wonder if U7 now. I don't think these resistors are bad. Maybe U7200 is messed up. So PP5VS3 is enabled. I don't think 3V3. So this is our main issue, I think. Have you considered getting a camera hooked up to the scope? No. We operate off of the truss-based multimeter system. Paul in the chat sent me a multimeter, but the batteries, I mean, it would die every other day, so I couldn't keep up with it. So PP5VS3. Alright, I guess since U7200 almost looks like it had a crater. I don't think I need to replace the MOSFETs, maybe, but they don't seem like they're shorted, so I don't think that they're bad. Yeah, I don't think that had a crater. Let's see, so the crater is Paul, explain what just happened here. Open board view, and then I'm going to get out of here soon. If U7200 doesn't work, I will come back to this because I'm hungry. So the crater on U7200 is right here. I don't know. Alright, I'll try a new U7200. I don't think it's our issue at all. But it's, I guess, worth a try. But I don't think it's causing our issue. Now wait a second, I just got an idea. Before I take the hot air to the board. Yeah, I think our signals for the S3 rail might be messed up, so let's change this. Let's get microscope view back up. Sorry about that. There you go. Fine to me. This chip really doesn't die very often, honestly. I would replace the FETs if there was a shorter ground, but I don't think the FETs are bad. I think it's the signals from U7200 that are messed up, and that's causing our issue. That's my analogy, but if this doesn't work, I am going to get out of here because I've spent enough time on this board, and it's been ultrasonically cleaned and it's a mess. So, if you have a similar issue, good luck. Quarter fan spin is horrible. I don't wish quarter fan spin. Nice cam on the scope, thank you. How did I think since January or December? I don't remember exactly when I got it. I got the scope at the end of December. Finally said, okay, I'm done with my SE400, and so I got this one. This is an AmScope SM something or other. 7-45X, just the regular one that everyone has. Great scope. Highly recommend if you have an SE400 to upgrade to an SM series scope. It's a huge difference. I remember everybody telling me that, you know, I always thought it's like, no, my scope is fine. I'll get a better scope. So the reason why I'm replacing the TPS 125, whatever it is because it had a small crater in it, and our signals are messed up, so maybe that's what's messed up on the chip. Don't just go replacing U7200 or U7200 because you see me doing it. Actually diagnose your issues. Please don't just start replacing stuff because you see that I did it on the video. You know, you need to use your own brain and come to your own conclusion of why you're replacing it. The answer, because I saw someone on the internet do it, is not a valid answer. You need to actually think. Alright. A little alcohol on this repair just to pull it down just a tad. Should be cool enough now. Let's plug it in. See if it works. I doubt it. And if it does, great. If not, I am going to get out of here. Oh, it would help if I plugged the fan in. And it's still quarter fan spins. So that means that I am done for right now, and I will come back on this board later. So thank you all for watching, and I will see you next time. Quarter fan spin issues are one of the worst ones that you can get, so these are not fun. Could be anything else, and I'll investigate why our S3 rails are pulsing a little bit more, and I'll probably come back on a stream if I do figure it out. But a word of advice is, if it's been cleaned, don't waste too much of your time on it, because it's probably going to be a no fix. So thank you all for watching, and I will see you next time.